All right, guys, here we go. Can't believe there's only 2 more weeks of this. Still pissy, but whatever. All right, so miss you guys for sure, though. All right, so this week is going to be all about segment length. So you've been dealing with arcs and angles and that sort of thing with respect to circles. Now it's going to be specifically lengths. Still with secants and tangents and chords, but we won't be talking about arcs or angles. So no degrees in this, just purely actual measurements, lengths of these segments. All right, so the first theorem, there's 3 theorems you got to learn today. I'm going to do this one theorem in the theoretical, and then 2 examples, one easy, straightforward, one more annoying and complicated, but not rocket science. So stay with me, and then I'll move on in the second video to the others. All right, so theorem. If 2 chords, so remember chords, so like C, D is a chord, on the circle, the endpoints are on the circle. If 2 chords intersect within a circle, so I got C, D, and A, B, intersecting here at E, right? The product, right, fancy math term, 2 numbers multiply to give you this answer. Product of the measures of the segments of one chord. So the measures of the segments, the pieces of one chord. So CD is CE and ED. Those are its segments. So the product, the multiplication of this piece times this piece is equal to the product of the measures of the segments of the others, is equal to this piece times this piece. All right? So what you're looking at here is AE times EB. So together, AE times, so that's this piece times this piece, right, is going to be equal to those 2 pieces multiplied. CE times ED. All right, so AE times EB equals CE times ED. Some people call that product of the parts. All right, so that's pretty much it. Now the theory behind this, which we'd go into more detail if I had you in class, is you could always connect this. You can see there's like little tight dash lines that connect, and you make these into 2 triangles. And if you're looking at that, you could be like, oh, okay, well, hold up. What you can get here is you got, bam, vertical angles. And then what you really have is this angle right here, C, is an inscribed angle to this arc AD. But B is inscribed to that same arc. So really, these angles are congruent as well. And for that matter, A and D are congruent because they're inscribed to CB. So long and the short of it is you'd be able to prove these 2 triangles are similar. And with similar triangles by angle, would be able to use your CSSTP, all right? And you'd be able to write sides in proportion, and then you'd cross multiply, because this looks like a product. All right, a product of the means equals product of the extremes, or POM equals PO, and that's where this comes from. All right, that's the theory behind it. What you need to know is that CE times ED is equal to AE times EB. All right, sometimes when I'm reviewing this, I'll put like little letters like A times B equals C times D. It's just another way of showing it. Okay, now, the application. So if I gave you this problem, I just copied the same exact figure. So if this piece CE was 4 and this piece ED was 6, all right, they together make that chord, and 3 and X, you'd be able to write as simple as it gets, 4 times 6 equals 3 times X. And then solve your little 7th grade equation. 24 equals 3X, divide, X equals 8. All right? Now, that's as easy and straightforward as it gets. The annoying version, not that it's rocket science, is something like this. Okay, well, same concept. So you got 4 and 4, even though it's not drawn to scale, right? And you could say, fine, 4 times 4 equals, and then you say, multiply these 2 pieces, x times x plus 6. But what you wind up getting in this situation is a quadratic equation, all right? You'd have to move the 16 over, you'd, double parenthesis action, you'd factor, you'd wind up getting x plus 8 and then x minus 2, which would produce answers, as I run out of room, of x equals -8 and x equals +2. Now, obviously, this segment AE can't be -8, so you would discard that answer, right, which would make this 2, right, and this 2 plus 6, 8, and then hold up, 2 times 8 is 16, 4 times 4 is 16, it checks you're good. All right, so hopefully that makes sense. and we'll take it on to the next two theorems, which are actually, I think, easier. All right, bye.